A circle is the locus of all points equidistant from the center. We denote the center by h, k, and any point on the circumference is x, y. And that distance, which is common, we know it's the radius. So radius is basically that distance which is constant. Now, using this information, let's try and construct an equation for the circle. We will have to use this property that the distance of any point on the circumference from the center is constant. It's actually equal to the radius. So if I use the distance formula, that's x minus h whole square plus y minus k whole square under root. This is the distance of any point on the circumference from the center. This we know is equal to r. Now just to remove this radical, what we can do is to square both sides. So when I square both sides, what we get is x minus h whole square plus y minus k whole square equals r squared. This is the standard equation of a circle. Now you can be asked to state the center and the radius of a circle. Given the equation in the standard form, you can be asked to find the center of the circle and the radius. So if you remember the standard form, all you have to do is compare the terms. So if I compare the terms, instead of h I have a 3, instead of k I have a 2. So which actually means that h comma k is 3, 2. So our center is 3, 2. On the right hand side we have r square. In this case that's 25. So r square is 25. Hence r is 5. That's the radius. Now in this circle what we have is x plus 3 and y. So if I compare x plus 3 whole square to x minus h whole square, what I get is x plus 3 is equal to x minus h. Hence h is minus h is 3. Therefore h is minus 3. Just be careful with the signs. In the general form, in the standard form, I have a minus sign, but here it's a plus 3. So it actually means minus h is plus 3. Hence h is minus 3. Now, when I compare these two, there's nothing being subtracted from y in this one. When there's nothing, it's actually a 0. So what I can say is that y minus k square is corresponding to y minus 0 whole square. There's nothing being subtracted. I can say this is y minus 0 squared. They mean the same thing. So the idea is when there's nothing subtracted, it's actually 0 and hence k is 0. The center is minus 3, 0. Now for the radius, we just compare r square to the constant on the right hand side. That's r square equals 49. Therefore r is 7. Now if you're unsure about the signs, what you can do is you can just equate the squares to 0. There's one square which is x plus 3 square. When I equate this to 0, what I get is x equals minus 3. This is the x coordinate of the center, which is h. Similarly, I can equate y square to 0, and what I get is y equal to 0, which is the y coordinate of the center, which we call k. So here as well, h comma k is minus 3, 0. So this is something you can do to find the center of a circle. Now let's take one more example. Now this is the equation of a circle given to us. Again the standard form. We still have to find the center and the radius of the circle. So I'll start off with comparing the squares. X minus h square is basically x square, which means h is 0. Once again, x square basically is x minus 0 whole square. When there's nothing being subtracted inside the square, there's a 0 being subtracted. So that gives me h as 0. Similarly, in place of minus k, I have plus 5. That's minus k equals plus 5. hence k is minus 5. The center is 0 comma minus 5. Or alternately, what you can do is just equate the squares to 0. So x square or just x equal to 0 will give you x as 0. That's basically h. For k, you can equate y plus 5 or y plus 5 squared to 0. That would give you y as minus 5, which is k. So from here as well, h comma k is 0 comma minus 5. Finding the radius is very easy. Just don't forget about the square. 4 here is actually equal to r squared. Not just r, but r squared. So if r squared is 4, r is just 2. So that's the radius. Now the next thing we have is the diameter. I hope we all know what diameter is, right? It's just a chord, a straight line joining 2 points on the circumference, let's say A and B, such that it passes through the center. This is the center. Now, this diameter has the following properties. The midpoint of the diameter is the center of the circle. So basically, if I have the end points of a diameter, let's say A and B, midpoint of A and B will give me the center h comma k, and to find the radius I can find the length AB, divide that by 2, it would be equal to the radius. Now once you have the center and the radius, you can easily construct the equation of a circle. Now this is the information we have. There is a diameter AB and the endpoints of the diameter are given to us. Using this information, we have to construct the equation of the circle. Now I'll begin with the general formula, which is x minus h whole square plus y minus k whole square equals r square. So basically, to get the equation of the circle, I need h, k and r, where h comma k is the center, r is the radius. Now we just discussed that the center h comma k is just the midpoint of the diameter, which is midpoint of AB in this case. That's minus 6 plus 2 upon 2, comma 9 plus 3 upon 2. That's minus 4 by 2, which is minus 2. 9 plus 3 is 12 upon 2 is 6. This is the center, h comma k. Now to find the radius, I'll have to first find the length of AB, which is 9 minus 3 squared plus minus 6 minus 2 squared under root. This is 9 minus 3 is 6, that's 36. Minus 6 minus 2 is minus 8 square is 64. This is root 100, which we know is 10 units. Now this 10 is not the radius, it's the diameter. Radius is half of the diameter, which is length AB upon 2, which is 5. Now once you have this information, you can easily construct the equation of the circle, which is x minus minus 2 squared plus y minus 6 squared equals 5 square. So that's x plus 2 whole square plus y minus 6 whole square equals 25. Now this is one more example, same concept. Again, we have the endpoints of a diameter and we have to construct the equation. So let's first find the midpoint of CD, because that is the center. That's 2 minus 2 upon 2, comma 3 plus 6 upon 2. This is 0, comma 9 by 2. So this is basically the center of the circle. For the radius, I'll first find the length of CD, which is 6 minus 3 squared plus minus 2 squared, entire thing under root. That's basically 3 square, which is 9, plus minus 4 square, which is 16. That's root 25, which we know is 5 units. But again, this is not the radius, this is the diameter. Radius is the length of the diameter upon 2, which is 5 by 2. and the general form is x minus h whole square y minus k whole square equal r square, which we know now is x minus 0 is just x, so that's x squared, plus y minus 9 by 2 square equals 5 by 2 whole square. If r is 5 by 2, r square is 25 by 4. So this is the equation of this particular circle which has a diameter CD. Now the next thing is to check whether a given point is on the circle or not. Now this is a very simple concept. If I give you a point, let's say 4, 2, and I ask you to check whether this point is on the circle or not, all you need to do is plug in the values in the given equation and see if this gives you a true statement or not. So if I plug in x as 4, I get 4 minus 3 whole square plus 2 minus 2 whole square equals 20. I'm just copying the values as it is. If I simplify the left hand side, which is this one, I get 1 square plus 0 square, which is 1. Right hand side is 20. Clearly this is not a true statement because 1 is not equal to 20. Hence I know that this point does not lie on the circle. Now let's check for this point 7, 4. Approach is the same. Plug in x as 7, that's 7 minus 3 whole square plus 4 minus 2 whole square equals 20. Now 7 minus 3 is 4, that's 4 square plus 2 square equals 20. 4 square is 16, 2 square is 4, so 16 plus 4 is 20. Now this is what we call a true statement because 20 is equal to 20, which implies it does lie on the circle. Now an extension of the previous concept is that if you have a point, it can either lie on the circle or not on the circle. But to generalize, there are 3 different possibilities. If you have a point, it can be on the circle, it can be inside the circle, it can be outside the circle. Now how do you check which is the case for a given point? It's very simple, it's very commonsensical in fact. If I talk about the distance of A from the center, this should be equal to the radius because it's on the circumference. If I talk about distance of B from the center, now if you look at the point B, it's closer to the center as compared to the points on the circumference. So this distance has to be less than the radius. Similarly, if I talk about distance of C from the center, now this point C is further away. From the center onto the circumference, this is R, but this is beyond R. So this distance is more than R. This is exactly how we check for the point, whether it lies inside the circle, outside the circle, or on the circle. It's just the comparison of the radius to the distance between the point and the center. Let's take some examples on this. Now let's say this is the circle given to us and we have to check for these points 2, 3, 3, 5 and 6, 4. Let's begin with 2, 3. Now before that I'll have to identify the radius and the center. So for this circle, the center is 3, 0 and the radius is square root of 25, which is 5. Now to check for the location of this point, I'll have to find the distance of this point from the center, which is 3, 0. That's 2 minus 3 whole square plus 3 minus 0 whole square under root. This is root 10. Now root 10 clearly is less than 5, so this point is inside the circle. If I check for 3, 5, 3, 5 would be 3 minus 3 whole square plus 5 minus 0 whole square under root. This is 5, which is equal to the radius, hence this is on the circle. Similarly, if I check for 6, 4, that's 6 minus 3 whole square plus 4 minus 0 whole square under root, that's 9 plus 16 root 25, which is again 5. So this is also on the circle. Let's take one more example. Let's say we have a point which is 7, 4. So 7 minus 3 squared plus 4 minus 0 squared under root. Now this would be 16 plus 16 root 32, which is greater than 5. Why? Because 32 is greater than 25. If I just square both the quantities, I get 32 and 25. We know 32 is more than 25, hence root 32 is more than root 25, which is 5. So this point is outside the circle. Now the last thing in circles is basically to identify the center and radius, but using the expanded form. This is the standard form, the whole square form. For the same equation, I can also find the expanded form, which is just the expansion of these squares. That's x square minus 2hx plus h square plus y square minus 2ky plus k square equals r square. Now in the general or the expanded form, what we do is we first make one side 0 always. So if I do that and I rearrange the terms, I'm writing the squares first. X square plus y square minus 2hx minus 2ky plus h square plus k square minus r square equals 0. Now this is the expanded form of the same circle. Now I did give you a shortcut to find the center and radius from this form. What I said was, for h, you can use the coefficient of x and divide that by minus 2. For k, you can use the coefficient of y, divide by minus 2. And for the radius, what you can do is you can use h square plus k square minus r square equal to the constant in the equation. Now the reason is pretty simple. If I look at these terms, this is where I see an h. This is the term in x. If I talk about the coefficient of x, that's just minus 2h. So if I divide minus 2h by minus 2, I get h. If I look at this term which is in y, the coefficient is minus 2k. If I divide this by minus 2, I get k. So that is why I can just use the coefficients, divide them by minus 2, I get h and k. For the constant, this is what the final constant in the equation would be. That's basically also h square plus k square minus r square. So I can equate this entire thing to the constant given in the equation, and from here I can solve for r because I already have h, I have k, I have this constant in the equation. The only unknown is r square, which I need to find. Let's take one example of this. Now let's say this is the equation we have. This is not the standard form, this is the expanded form. Given this form, we have to find the center and the radius. Now if you remember the shortcut, I can use coefficient of x, which is just 2 upon minus 2, that is minus 1. So h is minus 1. For k, what I can do is I can use the coefficient of y, which is 4 upon minus 2, that's minus 2. So h comma k is minus 1 comma minus 2. Now for the radius, I can use h square plus k square minus r square equals constant, which is 1. This is the constant in this equation. Now this is 1 and I already have h and k. That's minus 1 squared plus minus 2 squared minus r square equals 1. From here I get 1 plus 4 minus r square equals 1. If I simplify this, I get r square as 4, hence r is 2. Now let's discuss the reason again. If I start off with x minus h whole square plus y minus k whole square equals r square, if I expand this, I get x square minus 2hx plus h square plus y square minus 2ky plus k square minus r square equals 0. One side has to be 0 in the general form. Now rearranging the terms, I get x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square equals 0. Now this is from the standard form. If I look at this given equation, I need to find h, k and r. So in the expanded form I see h here, which is in the term of x. So basically minus 2hx will help me find h from the given equation. So since these are two same circles, the terms have to be exactly the same. So minus 2hx has to be 2x. So the idea is if I try solving for h, I'll just ignore the x or just cancel the x both sides. What I'm doing is I'm dividing 2 by minus 2. Now what is this 2? This is the coefficient of x in the given equation. Therefore h is minus 1. Similarly for k, I see a k here in the term in y. So if I compare this term in y to the term in given equation, which is 4y, again cancel y both sides or just ignore it, what I'm left with is minus 2k equals 4. Therefore k is 4 upon minus 2, which is again minus 2. Now what is this for? This is the coefficient of y in the given equation. So that's how we can find h and k in the expanded form. The last thing is this r. Now in the equation I see r here in the constant. Constant is basically without x and y. There's no x, there's no y in these three values. So these are the terms which will give me the combined constant, the final constant. If I look at these are basically h square plus k square minus r square, which is the final constant in the equation. If I look at this given equation, this final constant corresponds to 1. So if I have h and k, which are minus 1, minus 2. So h square is 1, k square is 4. So therefore r square is 4, hence r is 2. Now this is one more equation, not in the standard form but the expanded form. We again have to find the center and the radius. Now if you use the shortcut directly, we can use coefficient of x to find h. The coefficient of x is minus 2. That's minus 2 upon minus 2, which is 1. Hence h is 1. Similarly for k, I can use the coefficient of y, which is just 4. 4 upon minus 2 is minus 2. Hence the center is 1 comma minus 2. Now for the radius, it's h square plus k square minus r square equals the constant when one side is 0. Now that is the thing here. We do not have the side as 0. There is no side as 0. So before finding r, I'll have to first rearrange this, and that would give me x square plus y square minus 2x plus 4y minus 20 equals 0. That is how we make one side 0. Now once you've made one side 0, you can now pick the constant. H square is again 1, k square is still 4, r square, but now the constant is minus 20. It's not 20, it's minus 20. So first we make one side 0, then we pick the constant. Now from here, if I try solving for r square would be 25, hence r is 5. Right. Once again, just to revisit the reason behind it, the expansion would be, the starting form would be this. So that's again x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square equals 0. Now I am just using the expanded arranged form. You can open the squares and rearrange the terms. Write the squares first, then the linear terms, and then the constants. Now if I compare this to the given form, x square y square are the same. ये तो same ही है दोनों में. Then we have a term in x. So again I can use minus 2 and minus 2h to find h. That's basically minus 2 upon minus 2, which is 1. Similarly, if I compare the terms in y, I can use 4y and minus 2ky to find k, which again is 4 upon minus 2, which is minus 2. And this entire thing is the final constant in the equation, which is h square plus k square minus r square, which we know in this equation is minus 20. So hence, I solved for r and got r as 5. Now let's take this example. Again, this is the expanded form, and I have to find a center and radius. But again, there's no side equal to 0, so first I'll rearrange this. I get x square plus y square plus 4x minus 45 equals 0. Now this is one thing, but there's one more thing here, that I don't see any term in y. So when there's no term, it actually means the coefficient is 0 or the term is 0y. Always remember, when there's no term, it means the coefficient is 0. So if you see no y here, it actually means it's 0y. Now once you have this rearranged form by making one side 0, you can find h by using coefficient of x, which is 4 upon minus 2. That's minus 2. For k, we can use the coefficient of y, which is 0, and 0 upon anything is 0. So basically the center is minus 2 comma 0. For the radius, again h square plus k square minus r square equals to constant. When one side is 0, we've made one side 0, so that constant is actually minus 45. H is minus 2, h square is 4, k is 0, so 0. From here I get r square as 49, hence r is 7. So the radius is 7. So this is all about circles. Let's try some MCQs. Now these are some MCQs on circles. Now the first one is in the equation, which is right here. You have to identify the center. Now if you remember correctly, the form is x minus h whole square, y minus k whole square. So h clearly corresponds to 3 and k is 2. So the center basically is 3 comma 2, which is the first option. Now if you're unsure about the signs, what you can do is you can equate x minus 3 to 0. That would give you x as 3, which is h. And you can equate y minus 2 to 0. That would give you y as 2, which is k. Okay. In the second equation, we have to state the radius. Now, if you remember correctly, on the right hand side, it's not r, it's r square. So, r square is 4, hence r is 2. The third one is, we again have the equation of the circle and we have to still find the center. Clearly center is h comma k, which is 4 comma 3. Now we have been given the center and the radius. We have to identify the equation. So I'll first write the general form, which is x minus 0 whole square plus y minus 0 whole square equals r squared. So that's x square plus y square equals 9. That's this option. Now next we have is the diameter of a circle which has a length of 12 and the center is minus 5 comma 2. So first thing, if the diameter has a length of 12, radius we know is 6 because that's half the diameter. And h comma k is minus 5 comma 2. So that's x minus 5 squared plus y minus k squared equals 6 squared. That's x plus 5 squared plus y minus 2 squared equals 36. Basically option C. Now again we have the center and radius. We have to identify the equation. x minus 3 whole square y minus 4 whole square equals 2 squared. That's x minus 3 squared plus y minus 4 squared equals 4, which is option D. Okay. Now in this next question we have to identify which of the points lie on the circle. So we have the equation. Now to check, what you can do is you can plug in the points and see which one satisfies the equation. If I look at the first one, that's 4 squared plus minus 4 plus 2 squared equals 40. Now 16 plus 4 is not 40. Hence this is not the correct answer. Let's try minus 2 comma 4. So minus 2 squared plus 4 plus 2 squared equals 40. This was A. We're checking for B. That's 4. 36. Yes, 40 is equal to 40. This is a true statement, which means this point lies on the circle. Right? So you just plug in the points in the equation and quickly check which squares add up to 40. There has to be only one answer, so I got the answer. Moving on. Now last two questions. Again we have to check for the point on the circle. So if I use the equations, 5 minus 6 squared plus 4 plus 8 squared equals 100. Clearly this is 12. 12 square is 144. So this can't be the case. It can't be 5 comma 4. You can simplify this further if you want, but it's very obvious. 4 plus 8 12 है. 12 का square 100 से बड़ा होगा. So it's not going to satisfy the equation. If I check for minus 1 comma 0, minus 1 minus 6 squared, 0 plus 8 squared equals 100. Minus 1 minus 6 is minus 7. 49 plus 64 is not 100. So this is not the point either. If I check for 3 comma minus 2, 3 minus 6 squared plus minus 2 plus 8 squared equals 100. 3 minus 6 is minus 3, which is 9, and 6 36, again not 100. So it has to be the last one, but let's check. Minus 2 minus 6 squared plus minus 2 plus 8 squared equals 100. Minus 2 minus 6 is minus 8. Minus 8 squared is 64. Minus 2 plus 8 is 6. 6 squared is 36, which is equal to 100. So yes, this is the point which lies on the circle. Now the last one says you have the circle given to you, in fact, and you have to identify the equation. Now this is the circle. You have to identify the center and the radius. Once you get the center and radius, you can easily identify the equation. Now this K is the center, which clearly is minus 1 comma minus 1. This is minus 3 minus 2 minus 1, minus 3 minus 2 minus 1. Now for the radius, you can use any of the distances. You can use this distance. This is 3 units. You can use this distance, 3 units. Any distance you can use, you will see the radius is 3. So you have the center and the radius. Now it's easy to identify the equation. Let's construct our equation. That's x minus minus 1 squared, because h is minus 1. Y minus, again, minus 1 squared equals 3 squared. So if I open the brackets, that's x plus 1 whole square plus y plus 1 whole squared equals 9. So that's basically this. Okay. So this is all about circles. If you have any questions, you can let me know. Just email me or WhatsApp me.